Okay, this is another example of predicting redox reactions. Luigi, having copper 1 from the amalgam and the fillings in his mouth, accidentally bites off some aluminum foil while taking a bite of his salted frog legs. What redox reaction occurs in his mouth? So in his mouth, he's going to have water. It says he has copper 1 from the amalgam and his fillings. It says he accidentally bites off some aluminum. Aluminum foil is it as an element, so there's no charge there. And it says that he's eating salted frog legs. So that's going to give me sodium and chlorine ions. So those are all of the possible things. So now what we're going to do is we're going to look carefully and we're going to see which of them are available as oxidizing agents, ready to oxidize something else or get reduced themselves, and which of them are available as reducing agents. So remember, the oxidizing agents are on this side and the reducing agents are on this side. So we're looking for these guys on either side. So Cu plus 1 is right here. So that's an oxidizing agent, and he won't appear anywhere on the right. Aluminum, on the other hand, is right here. So that could possibly act as a reducing agent. Sodium plus is way down here. So he's an oxidizing agent, but he's pretty weak, so we're not too worried about him. Chlorine is up here, so that's a reducing agent. And water is here somewhere. There it is. And that's going to be an oxidizing, sorry, I'm putting reducing agents on the bottom. That's going to be an oxidizing agent, but again, a pretty weak one. So what we want to see, if we're going to have a reaction happen here, is we want to see the oxidizing agent above the reducing agent. So remember, the strongest oxidizing agents are the ones at the top. So fluorine is the best at oxidizing somebody else, stealing their electrons. And aluminum is a pretty good reducing agent, pretty good at giving up its electrons to form Al3+. So here, our strongest oxidizing agent is the copper, as that's the one that's on top. And our strongest reducing agent is the aluminum, that's on the bottom. And the sodium and the chlorine are both really weak, so they're not going to participate. They're already in a state they really like to be in. Sodium likes to be +1, chlorine likes to be -1, so they don't really want to go the other way. And water could have acted as an oxidizing agent here, just copper is a stronger one. So we'll write out the reduction of copper. When it's acting as the oxidizing agent, it's reducing, or it's getting reduced. So that's half of our reaction. And then we're going to write out the oxidation of aluminum. So we're going to take this one, but since he's acting as our reducing agent or getting oxidized, we're going to write it out backwards. And now we just need to balance these two things to make sure the number of electrons that are produced by aluminum are the same as the number of electrons that are consumed by copper. And then we can rewrite the reactions excluding the electrons themselves as they're balanced on either side. So that's it. That's the redox reaction that would be expected in this situation. And so in a weird way, this almost just looks like a single displacement reaction where the aluminum is effectively going into the solution and the copper is coming out of the solution. So that's how you can use the table just one more time to predict what's going to happen in a redox reaction.